use the row reduction algorithm to solve the system. So we have a system here of three equations, equation 1, equation 2, and equation 3. And keeping our row reduction algorithm in mind, we know that we want to begin by using x sub 1 in equation 1 and using it to eliminate the x sub 1's below it. But looking at this first equation, it doesn't have an x sub 1. However, looking at equation 2 here, this equation has an x sub 1 with a coefficient of 1. So let's begin by interchanging the first two equations. So the first thing I want to do is take equation 1 and switch it or interchange it with equation 2. So let's rewrite our system. This will become, we now have the system x sub 1 plus 3x sub 2 plus 3x sub 3 is equal to negative 2. Our second equation is now x sub 2 plus 4x sub 3 is equal to positive 2. And equation 3 still remains the same. We have 3x sub 1 plus 8x sub 2 plus 5x sub 3 is equal to negative 3. Alrighty, so now we are ready to take the x sub 1 of equation 1 and use it to eliminate the x sub 1 below it. So we think to ourselves, what do we need to do to equation 1 to eliminate the x sub 1 in equation 3? Well, if we take minus 3 times equation 1 and then add this to equation 3, we're going to end up with the new equation 3. So the first two equations will remain as they are. We still have this x sub 1 plus 3x sub 2 plus 3x sub 3 is equal to negative 2. We have x sub 2 plus 4 times x sub 3 is equal to positive 2. And now just be careful here as you do this manipulation. We're multiplying the entirety of equation 1 by a negative 3. So this negative 3 needs to be distributed to each term in equation 1. So this is going to become, we have negative 3x sub 1 plus 3x sub 1, which goes to 0. We're then going to have negative 9x sub 2 plus 8x sub 2 for a minus x sub 2. We're then going to have a negative 9x sub 3 plus 5x sub 3, which leaves us with a minus 4x sub 3. And this will be equal to negative 3 times negative 2 is 6 minus 3 leaves us with positive 3. And so we really don't even need to include that 0 there. All right, so notice in your new system, there is no longer any other x sub 1 terms. So we are all set. When we move to the second equation, so this is our second pivot position, and we want to use this x sub 2 in equation 2 to eliminate the x sub 2 below it. So this one's nice and easy for us. We can simply add those two equations together. So we're going to take equation 2 and add it to equation 3. And this will allow us to attain the new equation 3. So what is this going to leave us with? Well, our first two equations, again, remain as they are. We still have x sub 1 plus 3x sub 2 plus 3x sub 3 is equal to negative 2. Equation 2 is still x sub 2 plus 4x sub 3 is equal to positive 2. And now, last but not least, we want to combine equation 2 and equation 3 to get that new equation 3. So we have x sub 2 minus x sub 2 is 0. We have 4x sub 3 minus 4x sub 3, which is 0. So the whole left side has now gone to 0. And on the right-hand side, we have 2 plus 3, which is 5. And hopefully you're feeling uncomfortable. Looking at this, we think to ourselves, wait a minute, 0 is never equal to 5. And you're absolutely correct. This is a contradiction. So, what does this tell us? Well, this tells us that the system is inconsistent. since 0 is never ever equal to 5, this linear system is inconsistent. And what does a system being inconsistent tell us? There's no solution. So there is no solution to this linear system. And this is our beautiful final answer. So be on the lookout if you see a contradiction like this, where the left-hand side is 0, right? Because remember, the left-hand side is representing the variables. This first column here, or this third column, represents the variable x sub 3. So if you have 0 is equal to a non-zero constant, that's a contradiction. Because what this last row is telling us, in theory, is that 0 times x sub 3 is going to be equal to 5. But of course, 0 times anything is 0. So 0 equals 5? No way. That is a contradiction. So keep this in mind.